You're not good at them yet. So today we're starting chapter 5. We're going to be working on 5-1. Couple things I want to point out on this packet. There are 2 lessons that are under 6th grade. All the rest of them are under 7th grade. So make sure when you get on IXL and you go to do J1 and J2, you need to switch it to 6th grade. There are no 7th grade lessons that go along with that. Then the rest of them are all 7th grade. So today, 5-1 says I can write rational numbers as decimals. So we're going to be learning about decimals. And I can write rational numbers as fractions. So go ahead and shade in to see it there. And today we're going to be learning about writing rational numbers as both fractions and decimals. Shade in to see it. And then flip to 5-1. Yep. Go ahead and decode your first vocabulary word, rational numbers. Rational, yep. I'd probably do rational numbers. Rational numbers. So in the directions in this unit, you guys are going to see the word rational numbers a lot. A rational number is any number that, can be written as a fraction. Any number that can be written as a fraction. That's what a rational number is. So any number that can be written as a fraction. So a simple example would be 5/8. That's already a fraction. That's a rational number. It could be 2 and 7/9. That's written as a fraction. That's a rational number. Who thinks they could raise their hand and tell me why this decimal is also a rational? Raise your hand. Why is this decimal right here also a rational number? Because some decimals, in fact, most decimals are rational. Very good, because it can also be written as 1/2. So if you have any decimals, that can be written as a fraction, it's also a rational number. Who thinks they could raise their hand and tell me why that is a rational number? Oh, raise your hand. Why is 4 a rational number? Very good, because as a fraction, it's just simply 4/1. So rational numbers are any numbers that can be written as a fraction. This decimal right here, I'll give you a non-example, okay? This decimal is a non-example. Yes, that decimal that I just wrote, that is what we call an irrational number, which means not rational, because it just keeps going on forever and ever, and it doesn't repeat in a certain pattern. So like this decimal right here, 0.33 repeating, that is considered a rational number. And this is a very good question, so make sure you're listening. This is a rational number because all repeating decimals can be written as fractions. It would simply be 1/3 is 0.3 repeating. But this decimal, do you see a pattern at all? No. And then I've got those dots that show it's going to go on and on forever and ever. So that would be a non-example. That's not rational. Good question. That is rational because 0.7, you would read that as 7/10, which is written as 7 out of 10 as a fraction. So if it's a terminating decimal or a decimal that stops, it's rational. Go ahead. Yes. Oh my gosh, I'm giving you a pirate ticket for that. Pi is like the most famous irrational number. You're exactly right. Very good. I like that. Here's a pirate ticket for you. All right, now let's go down to, do you have a question too? Yep. All right, go ahead and decode terminating decimal for me, please. I'd probably do terminating, and then decimal. Terminating decimal. A terminating decimal is a decimal that ends or terminates. You guys know what it means to terminate something? It means to stop something. Oh yeah, okay, that's a gruesome example, but you're right. If you were to terminate something, it means like the end of something or the end of something's life. If you've ever watched any of those like secret agent shows, they'll have in the their job is to terminate so and so. So you're exactly right. Terminating means to end something. Like the Terminator stops. What does he stop? The Terminator. No, you're talking about like terminating bugs. Yeah, yep. A Terminator is somebody who stops bugs from investing in a house, like or overtaking. There is a movie Terminator. What does the Terminator stop? Does he stop crime? I think you're right. I think he is the crime. Anyways, the word terminate means to stop or to end. So a terminating decimal is simply a decimal that ends. So this would be an example of a terminating decimal. 2/10. It stops. It has an end to it. Another terminating decimal would be this, 0.375. Those are terminating decimals because they end. You could also have what we call a repeating decimal. So go ahead and decode repeating decimal. Repeating decimal. Repeating decimal. Repeating decimal. And a repeating decimal never ends. But for your definition, you want to say it is a decimal that repeats in a pattern. And it has to repeat in some type of pattern. So a repeating decimal is a decimal that repeats in a pattern. Yep. So like if you were to type into your calculator 1 divided by 3, you would get 0.33 repeating, and the 3's would keep going on and on forever. So you should write this example down. If I type 1 divided by 3, you see how I get that 0.333 repeating? If that screen were bigger, that 3 would keep going on and on forever and ever. Instead of writing a bunch of 3's, we just write that bar above the 3 to show that it's going to repeat. Now, watch what happens when I type in 2/3. It actually is a repeating decimal, but a lot of students think that it doesn't repeat because they see that 7. Anybody have a guess as to why that 7 is there? That decimal, if my screen were bigger, it would continue to say 0.66666 forever and ever and ever. The only reason the 7 is there is because your calculator is rounding. It ran out of room, and so it said, oh, this 6 is going to make this 6 round up to a 7. But technically, that would just keep repeating forever and ever. That would be an example of a repeating decimal, All right. Here is another repeating decimal. If you were to type in 1 divided by 11, you see how I get 0.0909090909? So it would be 0.09 with the repeating bar above it. Because the 0 and the 9 keep repeating in a pattern. 090909. They don't ever end. Nope, they keep going on forever. Now, you could also have a repeating decimal that might say 0.5, and then if it's got just the repeating bar above the 1, that means that the 1 is repeating, but the 5 is not. So it would look like this. So since that repeating bar is only over top of the 1 is repeating, but the 5 isn't repeating. Go ahead. Pi is not necessarily the biggest, but it's the most famous irrational number, is what I said. All right, so let's flip to our next page. Go ahead. What's that? Yes, it can. If it's 1/3, 1/3 is a fraction, and it's also a repeating decimal. Good. All right, let's jump to example 1. And in example 1, we have to prove that this is a rational number. A rational number is any number that can be written as a fraction. So if I want to prove that -12 is in fact rational, I have to write -12 as a fraction. Who thinks they could raise their hand and write -12 as a fraction for me? How do I write a whole number as a fraction to prove that it is in fact a rational number? -12/1. Very good. That's your proof right there that that is a rational number. Writing it as a fraction. All rational numbers can be written as fractions, so write it as a fraction. Now, this second example here, this is currently what? A mixed number. In order to prove that a mixed number is rational, we want to make it an improper fraction. You guys are more than welcome to use calculators. Yes, very good. Do you have a question or the answer? Yep. 2 times 15. So you're going to multiply 15 times 2. Multiply 15 times 2. And we get 30. And then you add the 11 to get 41. So 15 times 2 is 30. Plus 11 is 41. And then our denominator is still 15.